Okay, here we have a lesson on a proof of the Pythagoras' theorem using similar triangles. So here we have a right angle triangle and we've labelled it in a typical way. This is angle A and this is side A, that's little a. This is angle B and we use a capital B, and this is a little b, that's sides opposite B, and capital C and little c is the side. Okay, so we've drawn a perpendicular from AB and that goes up to C, and the point where that line meets AB is X, and I've called that height there H. I've also labelled this as X, and therefore this distance here is C minus X. Okay, so what we've actually done is created two similar triangles to the original one. So this one here is this one here. And the reason it's similar to the original is because we have the angle there, that's the same. We have a right angle, that right angle there. And this is angle C here. We've also created another triangle which is similar, and that's this one here. And if you see, we have the right angle again. CB is A there. Angle C must be that size because angle B is that angle there. So those three triangles are similar, and hence we can look at the ratio of their sides. The first one, I've looked at the ratio C to B, that's C to B there. So we take in these two triangles here, so C divided by B must be the same as B divided by X. So that ratio must be the same. And that gives us, just multiplying across, don't really like doing that, so Cx is equal to B squared. Now if we look at this triangle again, comparing it with this one, again if we look at C comparing it to A, and that ratio must be consistent if we look at the corresponding sides, and that this time is A and C minus X. So C divided by A must be the same as A divided by C minus X. I'm just going to rearrange that. So we get that, multiply that bracket out, so C squared minus Cx is equal to A squared, but Cx is equal to B squared. So I'm going to rewrite that as C squared minus B squared is equal to A squared, and we typically would write that as C squared equals A squared plus B squared, which of course is Pythagoras' theorem.